to your chemistry class. We have completed our term 1. We have written our term 1 exam. All of you have attended the examination. So, you're all good people, right? Everyone has attended the chemistry term 1 examination. So, I really want to thank all of you for attending your term 1 exam. Now we are in term 2. Till term 1 we have completed 3 chapters, right? Now we are entering into our next chapter, which is atomic structure. Already we have started with this. Can you remember? We have started, right? So once again I will have a quick glance on the topic what we have learned already, and we can start with the next heading. Listen, the first one is atoms, molecules and radicals. What's an atom? Smallest particle of an element is called an atom. This atom cannot be broken down. Consider hydrogen. This hydrogen atom cannot be broken down into smallest element than this atom. This is the smallest. Before atom we cannot break that. That is nothing but called atom. Some elements such as helium, neon, argon called noble gases or inert gases can exist as single atom. It does not need more than one atom. Even as a single atom it can exist in the nature. But some other atoms like hydrogen, oxygen, nitrogen, etc. it needs to obtain in the nature as molecules. The elements like helium, neon, argon, krypton, xenon, these are all noble gases. It can exist as single atom. So, molecule also has single atom. Molecule of helium is consisting of single atom. But some elements like hydrogen. See, this is the symbol for hydrogen. But when it is coming as molecule, you have to write H2. 2 hydrogen atoms combines to form hydrogen molecules. 1 hydrogen atom, 2 hydrogen atom combines to form hydrogen molecule. Now, molecule is a compound. It can be broken down. A molecule can have 2 atoms, 3 atoms. For example, hydrogen, only 2 atoms are there. Now, how we represent these molecules? Molecules has more than 1 atoms. We can represent these molecules using chemical formula. That is, chemical formula for hydrogen is H2, oxygen is O2, O3 ozone, nitrogen N2, etc. So, we represent these molecules by using chemical formulas. Then, another property of this chemical molecules is its atomicity. Depending upon the atoms a molecule has. For example, see this? Helium has only 1 atom. So, it is monoatomic. Hydrogen has 2 atoms. So it is called diatomic. Ozone has 3 atoms. So it is called triatomic. Then sulfur has more than 3. When it is having more, for example, phosphorus has 4 atoms. Sulfur has 8 atoms. So when it is coming more than 3, it is polyatomic. So what is atomicity? The number of atoms combined to form molecules. Consider hydrogen molecules, it has 2 hydrogen atoms. So atomicity is 2. Understood? Next one is valency. Valency is its combining capacity. For example, to form a compound, example H2O, this is combination of more than 1 element. So, combine this H2 and O, it needs some combining capacity. Hydrogen is there, oxygen is there. When it is combining only, we are getting water molecules. So it needs some combining capacity. It should have some combining capacity to form compounds. This combining capacity is called valency. Valency is a whole number. It will be varying from 1 to 8. Valency, how we denote? Ferrous. Valency is 2. We have to denote like this inside the bracket. Can you remember till this? The next one is ions. What's an ion? Ions means it will be a charged particle. How it is becoming a charged particle? By losing or gaining an electron. All the atoms will be having proton, electron and neutrons. When an atom is losing or gaining an electron or 2 electrons or 3 electrons, it is becoming as a charged particle. When an atom loses an electron, what it is called? See this. When this atom is losing an electron. When it loses an electron, it will become positive. When negative goes out, it is becoming positive, and this particular atom now it's called cation. In opposite of that, when it is gaining an electron, it is becoming negative charge and it is called anion. When it is losing an electron, the particular charge is becoming positive and it is called cation. And when it is gaining an electron, it is becoming negative and the particular charge is, particular atom is called anion. I repeat, listen. When it is losing an electron, the charge becomes positive and it is called cation. When it is gaining an electron or when it is accepting an electron, it is becoming negative and it is called anion. Clear? And the charge and the number of electrons accepted or loosed can be represented as superscript. Consider sodium. It is losing an electron, losing 1 electron. So it is becoming cation. Only 1 electron, so we are simply putting cation. Now consider this example, calcium. It is losing 2 electrons, so 2 plus. We have to represent like this in the superscript. Understood about ions? In your book clearly given the representation. Many examples are given for this. Sodium, calcium, many examples are given. You can go through that. Clear about what is ion? The ion is a charged particle when it is losing or gaining an electron. Next is radicals. Have you ever heard this word radicals? How many of you have heard this word radicals? What's a radical? Radicals means group of atoms that functions as a single unit in a chemical reaction and may or may not carry charge. Example you see, you can clearly understand. Take nitrate, NO3 minus. Radical is a group of atoms. It has 1 nitrogen atom and 3 oxygen atoms. So it's clear that it is group of atoms. Next, that functions as a single unit in a chemical reaction. It is a single unit, right? NO3 minus is a single unit, but it has different types of atom. Group of atoms that functions as a single unit in a chemical reaction and may or may not carry charge. it is carrying negative charge. So it is an anion. It is accepting electron and it is anion. It is having charge. In some radicals it won't be having charge. So you are clear about this? Group of atoms that functions as a single unit in a chemical reaction which may or may not carry charge. See this example. Two water molecule combines to form hydroxide, OH minus and H3O plus. This is an example for radical. From this OH minus and H3 plus are called radicals. This is a chemical reaction. You can combine this reaction with this definition. Group of atoms. It is having O and H. 2 atoms. It is having 4 atoms. 3 hydrogen atom and 1 oxygen atom. It is a group of atoms. It is carrying charge. Both are this is carrying negative charge and this is carrying positive charge. It is anion, it is cation. What's an anion? It is gaining an electron. Cation, it is losing an electron and may or may not exist, carry charge. It is carrying charge. So it's an example for radical. In this reaction, this OH minus and H3O plus are the radicals. In the book, many examples for radicals are given. Simply I have written only 2. Nitrate NO3 minus and hydroxide OH minus. You can go through your book. There is a table in that clearly the examples for radicals are given. Okay. Then the next one what we are going to learn is a representation of a compound. We have learned that molecules are represented using very good chemical formula. In the same way, the compounds are represented using chemical formula. How we derive this formula we are going to learn. You understood about this, right? Now how we are going to derive the chemical formula we are going to learn. See here, first part is you have to choose for which compound we are going to derive the formula. I have taken iron sulfide. You have to write the cation and anion. You have to write the cation first and anion second. The next step you have to write the valencies, but charge you should not mention. The valencies you have to write Fe2 S2. The valency of iron is 2, sulfur is 2. Valencies you have to learn. It's given in your book in the tabular column. And you have to now you have to interchange this valency. This valence you have to write here and this valence you have to write here. Fe2S2. Now you have interchanged the valences. Finally you have to divide by a common factor. See here both are 2, 2. So you can divide this 2 by 2, 1, 1 dv. So the chemical formula for iron sulfide is Fe. One more example I will say calcium hydroxide. Calcium, you have to write the cation first, anion second, and you have to write this OH inside the bracket. Now you have to write the valencies, calcium 2 and this OH 1. Then you have to interchange. This 1 will come here and this 2 will go here. Now you have to divide. There are 2 and 1. There is no common factor to divide this, so you are writing the same. So this is the chemical formula for calcium hydroxide. Now in your book many examples are given for this deriving chemical formula. You have to take your book, have to try for all the examples given in your book. You can try for new example also. If you want the name of the compound, you contact me, I can give you the name of compounds, so that for the particular compounds you can derive the chemical formulas. So I will repeat once again. Listen. First you have to write the cation, anion. Then next step you have to write the valencies. The next step you have to interchange the valencies. Finally you have to divide this valencies using a common factor. So that's all for today's class. In what are the things we have learned? We have revised our last class question, right? What's an atom? What's a molecule? How we represent a molecule? Atomicity. One more. Valency. Then, what's an ion? What's a radical? How we represent the compounds using chemical formula. These are all the things you have learned in your today's class. What are your works today? You have to learn the valencies of element. Then ions, cations and anions, you have to read clearly. You have to know what is an cation and what's an anion. What's an anion? When an atom loses an electron, it is becoming, when an atom accepts an electron, it is becoming negative charge. It is called anion. When an atom loses an electron, it is becoming positive charge. It is called cation. Should not forget this. Cation is positive. When an atom loses an electron, it is becoming positive and it is called cation. When an atom accepts an electron, it is becoming negative and it is called anion. Only when you go through your book, you read your book repeatedly, you can understand this. Then what is the heading? This chemical formula deriving. First you have to write the cation and anion. Then you have to write its respective valencies. Then you should interchange the valencies. Then you have to divide by a common factor if possible. If there is a common number to be divided, you can divide. Otherwise, you can write as it is. Clear about today's class? In the next class, what we are going to learn? In the next class, we will be learning about the significance of valency. You know what is a valency? Valency means the combining capacity of an atom. How many atoms or how many atoms required to combine with the other atom to form a compound. It is called valency. We have some significance for this valency. Valency is there. For what we use this valency? What is the importance of this valency? Valency, a number is there. 1 to 8, a whole number is called valency, and we have to know for what we use this valency and the importance of this valency. In this next class we will learn. And one more thing, you are all familiar about a word. Have you heard this word? What is this? Periodic table. For what we use this periodic table? What does this periodic table has? Anybody knows? What is there in this periodic table? Many elements are there, its symbols are there, atomic number is there, right? Have you ever heard this word periodic table? You all know this, right? So, what is there in this periodic table also we can learn in the next class. So, don't forget about today's work. You have to work out all the examples of deriving chemical formula and read on today's class. With this portions we can meet in the next class. Thank you. Have a nice day.